these questions. The first question we looked at was this triangle here. The question was as follows. It wanted us to find the angle at ABC. Calculate the size of the angle of ABC. So the way we do that is we need to understand what we mean by ABC. This is joining lines AB and lines BC, so it's the angle at B. So focusing on this problem, first of all, we've got to decide what kind of triangle it is. So what I would do is label it in terms of sides and angles to help us decide what kind of triangle it is. This is going to be an angle. I'm going to label it with a lowercase a for angle. This is a side, this is a side. This is an ASS triangle or SSA. For cosine, we need an SSS triangle or an SAS. So the easiest thing I ask myself is it a sus or sas triangle? No, it is not. Therefore, we're doing the sine rule. If we are doing the sine rule, we look for matching pairs. This means we're given 3 bits of information and the fourth we have to find. This is one pair, both bits of information have been given, and then the second pair involves the angle at ABC and the side here. Then what we need to do is we need to substitute into the relevant formula. This is the relevant formula for sine. This is for finding the sides. So if you want to find the side in a problem, we put the sides on top. The way we think of it is we put what we want in our lives on a pedestal. We put them on top of everything else. However, we actually want to find the angle, which is the capital letter. So we're going to flip this equation round. You might want to take a screenshot of this now. So the way we flip it round is as follows. We're going to take the equation, and instead of putting the small sides on top, we are going to be putting the angles on top. So we put sine of one of the angles, which we're going to call ABC, divided by the length of the side opposite ABC. So the length of the side opposite the angle at B is 19. Then sine of the angle at another vertex of the triangle is going to be sine of 60, and then the length of the side opposite this is going to be 17. We then need to rearrange, and there are multiple ways of rearranging this. What we're going to do is, first of all, we are going to move the 19. And the way I think about this is when we are doing calculations, and we have something we want to make subject to the formula, or we want to solve for ABC. We want ABC, our girlfriend or boyfriend, to be on their own. We want them all to ourselves. At the moment, they're connected with the sine and the 19. If it's a fraction, the first thing you need to do is get rid of the fraction part of this. And the way we do this is we think about the 19, and it's going to move up an escalator, and it goes, and it goes up to the other side of the fraction on the right hand side, and this is because we're going to times both sides by the 19. So we have sine of ABC, which is here. The original problem on the right hand side, sine of 60 divided by 17. Remember, you need to make sure you put brackets around the 60 in the calculator, times 19. Now you might be thinking, well, how do I do that on the calculator? So let's talk about how we would do that on a calculator. Let's minimize this page slightly and let's include our calculator into this. So you might have a different calculator to this, and this is absolutely fine, but this is what I'm going to be using. We are going to find where the sine is. The sine on my calculator is here. The sine of 60, make sure you close the bracket, that's a common mistake, divided by 17 times by 19. I've put 16 by accident, so just press delete and then press enter. Lovely, we've got a lovely decimal. You are going to expect a decimal, because this is not our last step. Our last step is to get ABC, or the angle at B, on its own. And the way we do that is we say that ABC is going to be equal to arcsine, with a Spanish calculator, or sine to the power of -1 of this number above. And we've calculated this number above to be 0.979. Now, if you can't be bothered to write down all the digits, just put a few dots, because you need to put it all in your calculator, but you don't need to write it all down. Then we're going to do arcsine. So we're going to press second onto the sine of this number 0.9, and then copy down as much numbers as you can, 6, 7, 9, 1, 0, 7, 4, 5, 4. And note, I've made a little bit of mistake here. It should be 7, 6, 7, 9. So I'll correct that now. And our answer is going to be as follows: 75.4 degrees. In the exam, I would round to the nearest whole degree or to 1 decimal place if it doesn't give the answer for what to do. Now let's look at the next question. Like before, we need to label the different sides. So let's label these. We've got S, A, S. Now this is clearly a SAS triangle. So as before, we're going to be using the cosine rule. We ask ourselves, what are we trying to find? We're trying to find QR, which is a side. So we go back to the original equations. The cosine rule, if you want to find the side, you are going to be using this formula: a squared equals b squared plus c squared minus 2bc cos a. The reason why is because we're isolating the a, the lowercase a, which is a side on its own. Now I'm going to label them as a, b and c. So the way we do this is by drawing as before. We want to find this side, so we're going to label the one we want to find as a, and then randomly label the other two as b and c. And then the opposites to the sides are going to be capital letters. We've done this lots of times in class. So we've got our relevant letters. Now we need to substitute this into the formula. And we're going to do the following. First thing we do is we get the formula as shown above, and we are going to just copy it down. A squared equals b squared plus c squared minus 2bc cos a. Obviously, when you're writing this, make sure you write this as a power, not as an arrow up like I've done on the computer. Then what we're going to do is we're going to start substituting in. When we substitute in, we are going to get b and c. Like I said, they can be randomly mixed up. So 22 squared plus 23 squared minus 2 times b times c minus 2 times these two numbers, 22 and 23, times cos of the angle 48. Then all you have to do, like before, is type this into the calculator. So we are going to do 22 squared to the power of 2 plus 23 squared minus 2 brackets 22 times 23 times cos of 48. So our cos is going to be here, 48. We need to put a bracket closure for the 48 and a bracket closure for the other bracket, then press enter. You can do this all in one go. It's a large number, 335. Last but not least, to find a, because this is a squared, we need to, guess what, square root it. So we need to find the square root. On my calculator, it's above the squared, so we're going to press second square root of this number, 335. Again, try and write down as many decimal places as you can. I'm going to delete this little mistake I've made here, 839. 8, I think that should be sufficient. Press enter, and that's going to be our answer, 18.325. So A equals 18.325. And remember, I didn't put the answer equal to 18.325 on this line of the equation because this is equal to a squared, and that would have been marked as incorrect. Right, let's go over question to do with finding the area. Now, the area ones are normally quite straightforward, but this is more complex, and I'm going to explain why this is complex. To find the area of something, you need to have two sides and then an angle encased between the two sides. So two sides and then an angle encased. But we don't have the angle, so we have to apply the cosine rule, but the angle format of it, to find the angle before we can apply this formula. So let's have a go at this. The first thing we need to do is we need to write down the correct formula, and this formula will be given to you in your M5 but not your D1 exam, so you need to remember this formula. Cos of A equals B squared plus C squared minus A squared over 2BC. If you want to memorise it, you have cos of an angle, then you have the opposite two letters squared added together minus this letter, but the side version squared, divided by 2 times these two letters times together. Then you're going to substitute it in. We are going to find the angle at C. So rather than using these original letters A, C and B, I'm going to relabel this as A, C and B, but I'm going to switch up the A and the C, and I will explain why I'm doing this. We want to find the angle at C, but in our formula we've called it A, so let's call that A and let's call that C. Just remember that from now on. So let's carry on with the problem. We then need to substitute in B, and B is going to be 10. C, well, we've said this is our new C, so this is going to be 9, and then 11, so it's going to be 10 squared plus 9 squared minus 11 squared, divided by 2 times 10 times 9. And you should see that working out here. Now you might notice there's something missing from our working out, and you might want to pause the video and think about what's missing in about 3 seconds when you can see the screen. Excellent, welcome back. Remember, we need to minus the a squared, and in our actual problem our a squared was going to be our 11, so we're going to minus 11 squared. So then we need to substitute this into the calculator. Normally for our class I recommend us to do the numerator and then the denominator. So our numerator is going to be 10 squared plus 9 squared. I'm going to do 9 squared in my head, which is 81, minus 11 squared, which is 121. And you can see I've made an issue here because I've put a little minus, which doesn't work on this calculator. So let's go again. 100 plus 81, so I'm doing the squares straight away, minus 121. 60, and our denominator is actually going to end up as 180, so it's going to be cos of A equals 60 divided by 180. So to find A itself you need to find the inverse of cos, so you're going to do second cos to the minus 1 of 60 divided by 180, enter. This is our angle, so our angle is going to be 70.528. Now, because this is not the end of our problem, I'd like to keep our angle to a few decimal places. Now, we can apply it to the formula. Our formula is 1/2 AB sine C. Let's take this as A, this is B, and then C is the angle encased within it. So we're going to do 0.5, which is the same as half, times 10, times 9, times sine of the angle, which is 70.528. Then we are going to get our calculator. We're going to do 0.5 times 10 times 9, which is 90, times sine, and then in the brackets we're going to do 70.528, close bracket. Our area of our triangle is 42.4 if you were to round it to one decimal place, 42.4 centimetre. And because it's area, it needs to be to the power of 2, so centimetre squared. I hope you found that video useful. Please let me know if you need any further clarification.